if we live or not. Starting stream, okay. Can you set up the phone?
Give me that phone.
It's all set up. All you have to do is hit go live when you get me in the frame. All right, everybody on YouTube, just give us 1 second while we set up the Facebook Live, and then we'll get started.
Yeah, you just won't see me, but it'll be fine.
Sure?
Yeah.
Go. Are we good? All right. Hello, everybody. Welcome to Dr. D's Discussions, Episode 7. Got a special co-host tonight. Rosa is going to be filling in for Nate and Lee. Happy Thanksgiving, everybody. Tonight's topic, we're going to be discussing the Anthropocene mass extinction event, a little bit of climate change, and the human impacts, and the what can we do? What are we causing? What are the bad sides to being the human species? So basically, Rosa, if you could just give us a little bit of a description about your background in education and what you're actually pursuing right now currently.
So currently I'm in a physician assistant program at Thomas Jefferson. I'm right now in the clinical rotations, but it's a lot to do in the medical field with helping doctors, helping nurses, helping nurse practitioners. So it's a very team-based approach type of job and atmosphere that I'll be currently getting into.
Excellent. Okay. I know she's a little bit cut out of the Facebook Live feed, so you're going to have to just deal with her voice coming in, chiming in. But yeah, just let us know if you have any questions about anything that we're going to be discussing tonight, and we'll go from there. All right. So let's talk about mass extinctions. What is a mass extinction? A mass extinction is when a significant portion of the species, in terms of percentages, are wiped off the face of the planet, literally. Usually it means that they're 50% or more where you just cease to exist. And there's been 5 other mass extinction events in the history of the Earth, starting with the Ordovician Silurian mass extinction, and that was 453 million years ago. And it basically was snowball Earth. And what I mean by that is glaciers took over the majority of the face of the planet so that all the sunlight that was actually coming in would be reflected by the snow and the ice caps, and it would actually cause more of a snowball effect.
So this is like a very environmental type of extinction that took place.
Yeah, and by environmental you mean it wasn't necessarily caused by anything in particular in terms of volcanoes, no, nothing in terms of eruptions. What I have gathered is that most of it occurred because a huge glacier was formed in the southern hemisphere of the planet, and as that kept creeping up, more sunlight would be reflected out, less heat would be absorbed by the oceans, and that caused basically a snowball Earth. So basically the entire planet was covered in just snow and ice, and that wasn't caused by any particular species of animals or plants or anything like that. But it was about 85% of sea life was extinct. And during this period of time, there was rare life forms on terrestrial land. So most of the life that we would see during this period would be like fish, bony fish, eels, and different things like that. A couple things like trilobites, the little trilobites that we always see in, old books or, museums and different things like that. And a trilobite is almost kind of related to a horseshoe crab. So imagine that horseshoe crabs lived through this mass extinction event till today. And it's one of the very few species that actually did. And then the next one along the list.
So just going back when you said that there was a huge mass extinction, was this more pertaining to the animals that were on land, or was it more?
There were very little land animals at this time because they had not evolved yet.
Okay.
And it's mostly messing of the chemistry of the oceans, basically, is what happened. And by changing the ability for the Earth to absorb heat and to release heat, it basically caused a huge ice age. Like we think about ice ages in terms of, when humans were first walking the Earth, in terms of, 20, 30, 40, 50,000, 60,000 years ago, where the glaciers would come down and then they would recede, come down and recede. And that's why you have the Great Lakes, you have the Finger Lakes, the Hudson River Valley, and different things like that. However, this was a ice age like none that Earth has ever seen before or ever since, because it covered the entire planet with a sheet of ice, like a huge sheet of ice. And there was water underneath, and things, sea life lived and eventually began to flourish again. However, at the time, not necessarily a good situation for any of those little fishies swimming around. But this is not the worst mass extinction event actually to be recorded. So the late Devonian period saw another mass extinction. This was 359 million years ago. And 3/4 of all the species on Earth died out, and it's thought that it was a series of extinctions over several million years. So a bad little time where a lot of plants and animals would die off, then you'd have a little bit of regrowth, die off, a little bit of regrowth, and then a hard die-off at the end. And basically, it was life in shallow seas that was most affected, and reefs, like coral reefs, like we're seeing in the Great Barrier Reef, where we see the bleaching, where the coral will actually spit out the algae that grows inside of it. So coral is a symbiotic animal that has the algae in it and animal portion of it. So it took 100 million years for this coral to get back to the point where it was before this mass extinction event. So think about it this way. You get onto, I want to use a highway analogy, but I'm blanking on it a little bit. But, it took, let's say you break your leg, and, you don't necessarily feel 100%, you can't walk right, you need to go through physical therapy. So think about the Earth going through physical therapy for 100 million years to get back to the point where it was before, in terms of diversity, in terms of how many animals there were, in terms of how abundant the coral actually was. So that's a pretty big physical therapy.
And what's the significance of coral in terms of two other animals that are living in the sea?
So coral is a good indicator of how the oceans are doing in terms of health, and it could be used as maybe like temperature taking. And that's the way that I would describe it to people. And the reason why I say that is because the coral is a good indicator of how life is doing, because it's a very fragile animal and plant, basically. And in that regard, it's good to determine, because it can only live at such an acidity and such a basic level of pH in the ocean. And if you go outside of its comfort zone, it dies off immediately. So it's a good indicator of how actually, life on the planet is doing. And if you think about it this way, and I know I posted this a little while ago on Facebook, is that coral reefs are like the rainforest to the ocean. There's so much diversity in 1 square kilometer that there's thousands of species in just this little area. So if you see a massive die-off in that area, it's a huge loss of biodiversity. And what that means for humans, because we're a greedy species, is that it's less fish, less drugs that we can find in these different compounds that are in these plants and different things like that. And it's also a huge indicator of how poorly the planet's actually doing. It's got a cold, so it's going to have these things die off. Or you can think of it as like pretty much like a bunch of zits.
Mm-hmm.
Your skin health is like really bad when you see a bunch of zits and it's all oily. So think about the coral dying in terms of like, oh wow, you have really bad acne or whatever. But let's move on. I want to get to the next. The Permian mass extinction was the Great Dying, where 96% of all species died. So think about it this way: the things that lived, the 4% of species that lived through this and past this, are what we and all the plants and animals all derive from. So there was a huge bottleneck in this time period. So it goes to show you that as though life is very resilient and sturdy and hardy, it can be beaten down, and it's fragile to a certain extent. Yeah, it'll come back, but it takes millions and millions and millions of years. And in this particular one, it was at least 2 separate phases of extinction spread over millions of years, Marine creatures were badly affected, so things that swim in the ocean. And many of the causes are, proposed causes are an asteroid impact, flood basalt eruptions, so volcanic eruptions that are releasing bad hydrocarbons into the atmosphere that'll block out sunlight. Kind of like nuclear winter, when you see everyone's like, oh no, the mushroom cloud and things like that. So it blasts all this soot and debris into the atmosphere, and it blocks the sun's rays, so the plants die, and then therefore plant-eating animals, herbivores, will die, and then
so it's disrupting kind of the food, the chain feed of like everything.
The ecosystem, yeah. So it screws up the food chain from the bottom to the top. And yeah, carnivores and omnivores such as us will live a little longer because we can exploit the resources around us, but it's not a very good picture to paint. Especially if you lose 96% of all life. So that's a pretty catastrophic event. And a couple other things: catastrophic methane release, which is something that we're seeing now in this mass extinction event, especially in the oceans. And a lot of people go, oh well, fossil fuels burn this, fossil fuels that, CO2 is bad. Methane is what's really, really horrible. Methane is a simple hydrocarbon, meaning it's just one carbon with 4 hydrogen atoms stuck on it. And it's got, I believe, 4 times the amount, or 4 to 10 times the amount of energy trapping ability than does CO2. So everyone hears about, oh, the CO2 levels are going high, the CO2 levels are going high. But the thing about it is once you get the CO2 levels to a certain point, that warms up the ocean bed, and the ocean bed starts releasing all the trapped methane that it has underneath it. And especially with fracking and different means that we're using to get natural gas, it's really holding us back in terms of, or it's actually accelerating the process. And everyone says it's better to burn methane because it's a cleaner fuel, which is true. Excuse me, but at the same time, it's not good for the environment, because once you tap a main of methane gas, it's harder to contain in terms of just oil. So when you tap into a main or a vein of oil in a big bottle, like a big bulb right there in the thing, in the Earth's crust, you tap it and you suck it out like a straw. So you pump basically particulate water and different things down to pump up the gas, because it's a different density. And with methane, you tap it, and it's kind of like a balloon, where if you tap the top of it and you poke a hole in a balloon, what's going to happen?
It's going to explode and you can't.
Exactly. And it's harder for you to contain all that. So that's kind of where we're at in terms of the mass extinction today, where, CO2 is not good and different things like that, but it could be a lot. It's going to get a lot worse. And it's one of those types of things that once you get the ball rolling, it's harder to stop. And that's really where we're at in terms of, burning fossil fuels and really killing off all the plants and animals in terms of just eating them or exploiting them for habitat, for agriculture, and different things like that. And we'll get into habitat loss in a little bit. But let's get through the last 2 remaining mass extinctions. The Triassic-Jurassic. So not a lot of people realize that the age of the dinosaurs had 2 mass extinctions. One that kind of killed them off and made them the dominant species in the world, and then the one that finally did the job in the Cretaceous period, the one that we all know about, the Yucatan Peninsula, with the big comet or asteroid coming and blowing up and killing the rest of the dinosaurs that were pretty much on their way out to begin with. So they were on their last leg. So it was kind of like the fight Alvarez versus McGregor. When McGregor, had him teed up, had his hands behind his back, and just waiting for that one last punch, and then drop. So the last 2 was climate change was one of the reasons why that there was a mass extinction event. There was a huge continent. I forget. I don't think it was Pangea. It may have been Pangea. It could have been. There's actually been 2 times when all the continents in the entire world were all mashed together in one supercontinent. It happened twice. But this was the one time where the periphery had life that lived, but in the center, because of how it came together, caused a drought. And I don't mean just like a couple years drought. I mean thousands and thousands and thousands of years of drought in the middle of this landmass. So the whole landmass came together. And around the fringe, you could have water and rain, and the cycle of, the water cycle can work pretty well.
Right.
But in the middle, there's no air currents and it dries out completely. Kind of like how Antarctica is. So basically some of the things that died out: marine reptiles, large amphibians, many reef-building creatures, again, coming back to reefs, as a good indicator of how the world is doing, and a large number of cephalopod mollusks. So mollusks like snails and different things like that, huge, like bigger than people, huge, went extinct. But strangely, plants didn't do so bad. They actually made it through pretty well. And then the last one, the Cretaceous-Tertiary mass extinction, 65 million years ago, the famed death for the dinosaurs. It's believed that they were on their way out to begin with, and this is kind of, like I said, the last knockout punch for a beaten and battered warrior or fighter in the ring. So, and we're currently going through this right now. We're in what's called the Anthropocene geological period. So there's eras, like the Mesozoic, which is when the dinosaurs lived or came to power, Paleozoic, and then the two before that, Proterozoic, and Mesoproterozoic. So basically, think about all life in the entire world that you know, animals, plants, fish, different things like that. They all arose around 500 million years ago, maybe a little bit before, in what's called the Precambrian mass explosion. So basically, all the little animals that were around before that in the Precambrian period were trying to grow bigger arms, like try different types of ways to grow.
Adapting in order to survival of the fittest.
Mm-hmm. And kind of on the same lines is that during this period, they've got segmented bodies. So when you look at a lobster, and you look at people, and you look at how interconnected and unique we look, but at the same time, we all come from a really basic building plan. We have a head, we have vertebra, we have legs that are segmented. You think about your arm. It's got a humerus, your ulnar radius, and then your phalanges and your carpals. So think about your feet and your legs. Same concept. One long bone, two smaller long bones, and then your toes and your feet. And we all come from these animals finally figuring it out and becoming a big body plan. And that's kind of fascinating to me. But at the same time, leads us to these different types of animals and why we should actually think of them more so along the lines as our support system. Because as much as we love ourselves and the species of animal that we are, it's going to be rather difficult for us to live without other animals. We kind of need to eat them.
Whether you're even a vegetarian or not, you still utilize, whether it's plant products or anything that grows from the soil or earth in order to feed our energy.
Exactly. And, it comes down to a couple things where, 38% of land vertebrate species. So vertebrates are animals that have a backbone, like us, dogs, camels, elephants. Fish would be vertebrates, but they're water, they're marines, so we won't include them in this statistic, but we'll get to them in a little bit. And the thing about it is that 38% of land animals are pretty much gone. Their population has decreased by 40% since 1970. That's only 46 years. So that we're basically losing biodiversity at 2% every year. So in the course of 50 years, almost, at this point, because it's accelerating, what are we going to have left in 50 years? So it's kind of a scary thing, and I don't want to be accused of being, fear mongering, but you better be afraid because our whole civilization is predicated upon eating animals, eating plants, and having agriculture. And if we overexploit that, because our population boom, going from 1 or 2 billion a century or two ago to 7 or 8, 10 billion in another 50 years. We're going to put a major strain on the world. So that's kind of like where I'm at when people deny climate change, and that's fine. You may not believe, and I hate the word believe, because you don't believe in facts. You understand them, you know them, and you try to understand them as the best of the ability that you can. But at the same flip side of it is, if you don't think there's something going on, and like that, we're not even going to touch on temperature changes in the world. We're not going to touch on that. We're going to touch a little bit on ocean temperature increasing, but we're not going to touch on that because I know everyone out there will go, oh, that's a conspiracy theory, and that's not this, and that's that. We're not even talking about that. We're talking about things that are tangible, like the loss of amphibians in freshwater. There was an 81% drop in freshwater species, and a drop of marine species of 36%. These numbers these aren't lying numbers, and I know the World Wildlife Foundation has their own agenda, but their agenda is basically to make sure that there's more animals around, to keep animals alive. And it may be a little hippie of me, but I like animals. I want my kids to see elephants. I want our kids to see sharks. I want our kids to see, trout and bass and pike and, frogs and fish. I don't want to be greedy by, killing them off all in our lifetime, rather than, looking ahead to the future generation to go, hey, maybe we need to ease up a little bit. And so just so you get an idea of where these statistics are coming from, I've noted the source here. It's the World Wildlife Fund, and they do a planet report every year, a biannual planet report. So it's 2 reports every year about the health and the well-being of our planet. And they base the levels on, the abundance levels based on 14,152 monitored populations of 3,706 different vertebrate species. And they all show a persistent downward trend. So, and what's one of the major reasons why we're having a loss? Plastics.
So that's what I was going to say, just in terms of your, the whole mass extinctions before, it was something that was, either something came onto Earth, whether it was asteroids, whether it was the actual Earth and the way, volcanoes or, an ice age. And it seems like right now what's going on are kind of human products and byproducts of what we are doing or how we're treating. From 1970 to now, that's not a, years of life extinction. That's a very short amount of time where we have a decrease.
That's one lifetime of people. My dad was born in 1966. So in his entire lifetime, we've seen this huge drop of about, all 81%, 36%, all those percentages. And it kind of makes you go, wow, maybe we are having a bigger impact on the world around us. And I know the argument from certain climate deniers or mass extinction deniers is predicated upon, oh, well, we're only one species. We can't possibly have a global impact. We can't possibly change how the Earth, operates, and how, we don't have the control over the climate. I understand that we've been warming and cooling naturally, of course, but to be so arrogant as to think that we don't have an impact on the world around us. Look at temperatures between the city and outside of the city.
Well, right now it's about to be December and it's 55 degrees.
And that's ridiculous. The North Pole was 35 degrees warmer just a few weeks ago than it should naturally be. And my whole thing about let's stay away from the temperature and plastics. They say that there's going to be more pieces of plastic than fish in the oceans by 2050. That's mind-boggling. There's going to be more pieces of plastic, like bottles, bags, wrappers, tires, condoms, for that matter.
So can you explain why is it that plastic is so bad for the one ocean environment as well as for the animals that live in there?
So there remains to be more empirical evidence and by empirical evidence, number-based evidence in terms of, does it cause cancer? Does it cause this? Does it cause that? We already know that plastics like bisphenol A and different things like polypropylene, the things that we will discuss with microbeads in a couple seconds, they do cause cancer, or they do have oestrogenic effects on certain species. So, meaning that they're going to have like estrogen. Females make estrogen, guys make testosterone, and that has a whole big impact on the way our bodies work and function, because hormones are literally what drives us to do what we do. It keeps our temperature down. It keeps us horny, and so to speak, to find a mate and different things like that. But it also allows our body to regulate itself and to communicate with one portion of it with the other. So you have a pituitary gland, and that releases luteinizing hormone, follicle stimulating hormone. For you, it'll make your eggs ovulate and go through your estrous cycle. For me, it makes me about sperm and testosterone and get all aggressive and angry for talks like this.
Right, and the body is a system. So, your kidneys, your lungs, all your organs, they're attached. Everything is attached to one another to make up who we are. And the hormones are what is going to get, by the regulation and up and down of what our body needs.
Exactly. So if you pump in these fake chemicals or these fake hormones, so to speak, it's going to throw your body into a little bit of haywire and cause it to be dysfunctional, which, as you may have known from last week, when you make cells dysfunctional, causes cancer, tumorigenesis, the start of making tumors. And the reason why, these are happening is because we have been pumping out plastics from oil and different things like that. So imagine taking the oil or the gasoline. You know how caustic that is. You smell it and different things like that, and you make plastics from it. And that's going to be eaten by fish. It's going to be eaten by snails, eaten by mollusks. And they say that, if you eat a kilogram of mollusks, like mussels now, you actually get 0.4, I think it's micrograms of bisphenol A in your body because of you eating just a kilogram or, 2.2 pounds, 2.2 pounds.
Right, so if you're eating the seafood that's then eating all of this, you're inherently going to get everything that they're
And here's just another picture. I posted this one earlier today, and here I wanted to talk about how this is going to be broken down. It would take centuries for this to be broken down naturally, just by in the environment. And it's not necessarily going to be broken down where you don't see it anymore and it's gone. It's poof. No, it's going to be in nanoparticles. It's going to be in micro pieces. There's a whole new set of research out there that's looking into what these micro pieces are actually going to do and what they can actually do in terms of affecting fish. So, or snails. And I know the example that I tell everybody with the microbeads, especially you, because I know that you like the exfoliating, feeling and different things like that. Don't get me wrong, I like it too, but it causes crabs to not be able to have sex. Their sexual organs shrivel up and wither away, and then they can't reproduce. There goes all the crabs. So these things do have an effect, and they're much bigger than what most people want to think about. And my whole gripe with humans are just one species, and we can't really impact the world. Look around us. We really are impacting the world. When you look at the night sky, from space, the lights are lighting up. There is a huge, big swath of humans everywhere. So I just hate the fact that people say, oh, humans can't have that big of a role in how the world works, like how it's dysregulated and things. And to you naysayers that believe in that, shame on you. Shame on you. We really do have a bigger role in the world around us, and that's kind of, where we have to draw the line and be like, oh, maybe we need to be a little smarter about the impact that we do have, and I'm not preaching off of a soapbox. I'm not calling anybody out in particular. I know that I have wasteful tendencies. I throw out more things that I should. I like beef, and beef is terrible for the environment because of methane and the agricultural way that they make it and all these different things for the environment. And, the type of agriculture that we do have in this country is predicated upon chemicals and fertilizers and different things like that. And, BPA, it's one of the plastics one of the pieces of the plastic that'll be found or constituent makeup of one of these plastics is commonly used as a model agent for endocrine disruption, which hormones in, the body. So your endocrine system is what releases hormones so the body can communicate with each other. And perinatal exposures as this environmentally born oestrogenic mimic, so it's an estrogen mimic, so it mimics estrogen, has been associated with mammary and prostate cancer in humans for at least 10 years. So think about it this way. All these little micro pieces, there's 20,000 micro pieces of plastic per square kilometer in the oceans. Wow. That's that's a lot. So, and it comes down to this, the microbeads and the micro pieces of plastic. The United Kingdom, by 2017, is going to ban microbeads. Europe's going to follow suit. And when they're ingested by small animals and fish, causes dysfunction of certain crab species' sex organs and systems. So it's like, say you're a normal person and you're swimming around in these microbeads and you're eating them, you breathe in, say you're a fish, you're breathing this in. And these little pieces are going to get stuck in there, and they're going to start emitting signals to the body to go, hey, you need to do this. Hey, you need to do that. But they're not the right signals. They're the wrong signals. They're going to make you have cancer and different things like that. So
we have a question. Are there any safe plastics that you can use, or are there any maybe alternatives that we can put our resources in?
That's a very good question. From when I was able to read, is that there are certain types of plastics that are okay. However, it's not necessarily the plastics that are. It's not necessarily plastics in general that are bad.
It's how we're disposing
It's
them.
just how we're disposing them. And there's actually new techniques of recycling these plastics that are coming down the pipe that literally use different enzymes found in plants, bacteria, fungi, different things like that we're actually going to be able to use to break down the plastics into their constituent parts and dispose of them properly. So it's not necessarily unsafe plastics, it's the means by which we get rid of the plastics in general. So
right,
it's
like
not
leaving plastic in the ocean versus maybe just littering it. You wouldn't have a fish obviously on the sidewalk, but figuring out how to dispose of it instead of littering the streets. So it's all
exactly
perspective.
And California's just banned plastic bags, so it's starting to take an effect. But my only worry is that it's too little, too late. So in hindsight, hindsight's 2020. We're gonna look back on this time period and go, wow, we were pretty wasteful and pretty unintelligent about how we disposed of different things. Where we just need to be a little smarter. And I encourage everyone to check out the links that I have here, and I'll actually post up the slideshow onto the Facebook Live in a little bit when we're finished. But check out the sources that I throw up onto this and the sources at the end, and I think you guys will be able to educate yourselves a little bit more in terms of what we can do for the plastics. I know that there's a bunch of countries like Denmark and I believe Norway that is going to reduce their footprint, their garbage footprint, to almost like 1% of where it is today based upon these new enzymes that are coming. So think about it that way. So better living through chemistry, so to speak.
Right.
And here's another little tidbit. In 2012, 288 million metric tons. In terms of U.S. tons, it's 317.5 million short tons of plastic were made worldwide.
I can't even fathom that.
That's a lot of elephants. That's like 300 million elephants worth of plastic. And microplastics originating in cosmetics entail between 0.04% and 4.1% of all plastics entering the marine environment. So they make these little beads that are no bigger than 5 nanometers across, and that can actually go right through the filtration of most city municipality water purification plants and different things like that. And they get dumped right into the ocean, and that's why crabs eat them, and little fish eat them, mollusks eat them. Mm-hmm. So they're absorbing these things, and then higher order species of animals, which what I mean by that is a little higher up on the food chain. So little crab, little plankton eats little plastics, they absorb it. Bigger fish, little fish, bigger fish, bigger fish, bigger fish, human. Mm-hmm. So eventually it's going to work its way up to us. And I want to turn our attention over towards ocean acidification and temperature increases. Over the past 300 million years, ocean pH, which is the level of whether it's acidic or basic. If you have a pool, you got to keep your pH at a certain level. You add chlorine and shock and different things like that. You add salts that raise it or lower the pH, so it keeps into an area where you don't have the green pool or the fungus, and the fungus among us. So it's been slightly basic, averaging around 8.2, and today it's around 8.1. And a drop of 1.1 pH units represents about a 25 to 30% increase of acidity, because when I say 8.2 to 8.1, that doesn't seem like that big of a deal. But pH is on what's called a logarithmic scale. And, and another similar thing that most people can relate to is Richter scale or earthquake size scale. So going from a 7 to an 8 on the Richter scale is a magnitude of 10 larger. And it's just that much more, it's a huge jump. The best way I could describe it is going from 10 people in a room to 100 people in a room. If you have a small room, you're going to be jam-packed. You're going to be like, oh no, there's too many people in here. I'm a sweaty guy, so, I don't want to be in a room with 10 times as many people. So it's 10 times more acidic than it was just even like a little while ago, maybe like 30, 50, 60 years ago. And this is directly correlated to the... Oh no, I can't change my thing. Oh no, I lost my slides. Oh no. Sorry guys. I don't know what's going on with my computer, but so basically what it means is the oceans currently absorb about a third of the human created CO2, which means 22 million tons a day. Mm-hmm. And like I had said previously, it doesn't necessarily mean that CO2 is that bad. It is pretty bad, but this absorption is causing warming oceans, and that's going to make underneath the ocean bed there's methane trapped that will start to bubble out and bubble up. Exactly. And it being 4 to 10 times more greenhouse gas absorbance and worse than CO2, it's going to start a chain reaction, a spiraling out of control, where we're going to see a huge increase of temperatures rather than the smaller increase in temperatures that we've been seeing that are usually...
But spikes of temperatures in both ways, right?
It's mostly just up in terms of this, because it's one of those types of events where, like I had said previously with the snowball Earth mass extinction, where once you covered enough of the Earth's surface with ice, it bounced off the rays of sun. So it got colder and colder and colder and colder. So with this, adding CO2 and adding CO2, it's going to get hotter and hotter and hotter. Or on the flip side of it, if you add CO2 to the bloodstream, so you know how oxygen is carried by hemoglobin or red blood cells. Most people would understand that.
If you increase your CO2, then you become more acidic.
Because CO2 doesn't go onto the red blood cells. It actually just gets absorbed into the blood, and it becomes bicarbonate, which is acidic. And that's why most people go, oh no, why would the oceans become more acidic? It's because of the bicarbonate, not necessarily the CO2. So you're causing this chain reaction, and it's just going to get worse and worse and worse and worse. And it's the oceans are a buffer. It keeps the world cool. It keeps the world warm, but it keeps it from going outside of its comfort zone. So think of it as, you don't want to be like Goldilocks and the Three Bears. You don't want it too hot, and you don't want it too cold. You want it just right. And that's what the ocean does in terms of acidity and temperature. So it's kind of where we're at, where it's not going so well for the oceans. And that's, you can see in this picture, just within 5 years, we've gone from coral being colorful and full of life to dead and devoid of life. And this is what's called coral bleaching. And this is happening all over the world in terms of the Great Barrier Reef is around 50% bleached because of the rising temperature. So the coral actually spits out the algae that's inside of it, and it dies. And I do kind of want to be able to see the Great Barrier Reef before it's all gone.
Can I just ask one question? So I thought bicarbonate is to make it more basic. If you have a hydrogen ion, which would be your acidity, and your bicarbonate, that would make things more basic. And the CO2 rise was why you would have bicarbonate in the body to compensate, but it wouldn't be.
Bicarbonate as a molecule has a positive charge, or negative charge rather. So it's going to pull off H's from the regular ocean water around it. So it's going to split it off and make it more acidic. Okay. So that's where that's how that works in very basic generic terms. And I don't want to lose too many people in getting into chemistry because I'm not really great at chemistry. But here's another thing that we can look at just from a purely empirical look is loss of habitat. Habitat loss poses the greatest threat to species. Think of forests, swamps, savannas, when you see a new development coming into your neighborhood or around your neighborhood, in the rural portions of your state or whatever, you're destroying natural habitat for species of animals and different things like that. And, where are they going to go? They're going to die. They're not necessarily going to be able to move to go somewhere where there's no human influence. So that's kind of the way that we're looking at the Amazon rainforest. It lost 20% of its forestation in the last 10 to 15, 20 years because of agriculture and ranching, in particular cattle. So, we're not necessarily doing ourselves any favors by expanding agriculture and different things along that nature, but we have to feed our species, but we can do this in a sensible, correct way where we still get to eat beef and different things like that, but we have to be a little bit cognizant of what we're doing to the world around us, not necessarily just hacking away and just building roads and pipelines and housing and different things like that. And my whole thing is, Asia's seen a huge deal of forest loss. North America is grassland and forest. Europe is, and Russia is. We're losing a very significant chunk of our, our habitat where these animals live. Like you almost lost 100 million hectares, or in just Asia alone. So you look at all this together, that's a significant chunk of land mass. And look at the percentage of the land. 44% of Asian land is converted over to agriculture and ranching and housing and different things like that, cities and suburbs, urban sprawl. So all these things have a negative influence on the world around us. North America, 27%. South America, 33%. That's the Amazon rainforest is being destroyed just because of human neglect and human indecency in certain respects. Now, I'm not saying that, there's smart ways to feed our people, and we need to think of new different sources of food, not just cattle and chicken and beef and pork. Beef is cattle, duh. But like bugs. Bugs take about a tenth of the space that cattle does, but they give you 10 times the protein per little area. So I know you're probably not thrilled to eat insects or crickets or whatever, but that might be something that we can think about in terms of.
I'm open to if it tastes good, I'll eat it.
Yeah, so I'll eat some crickets. Put a little teriyaki sauce on them. I'll gobble them right down. But we got to start being a little bit smarter about where we're getting our food from, and maybe even using urban farming. Converting old warehouses and different things like that, and doing indoor farming and different. Just smaller ways that they might be a little expensive right now, but in the long run, it could be greatly reduce the dependence that we have on these terrible practices that we have, around the country, around the world, and different things along that nature. Here, let's look at a little graph real quick. And this is species loss in the different areas. And I know that you see increases of 36%, 53%, and 5% across the Northern Hemisphere. But I want to just point out the fact that these areas has less density in terms of species than these areas. So think of it like comparing cities to rural areas, like Philadelphia to Harrisburg area, or York, or the middle of Pennsylvania, or let's even say the Great Plains, like North Dakota, South Dakota. If you had a 20% decrease of people in, say, North Dakota, that's what, like 100,000 people, just numbers off the top of my head. Don't quote me on those numbers. But if you saw a 25% decrease in people in Philadelphia, or the whole state of Pennsylvania, that's a significant chunk of people. That's millions of people. So the gains that you see up here are dramatically offset by the decreases down here. And these are the areas of the tropical rainforests, the tropical waters, and different things like that, where you have 10, 20, 30, 40 species in one small acre of land, as compared to up top where you have maybe 2 or 3 species per hectare, 100 acres. So that's kind of the difference where we're at, and it starts to paint a very bleak picture for the species around us. And by this time, you can't deny that whether or not you're a climate change enthusiast or a climate denier or whatever climate change term you want to use, we are going through a mass extinction event. And there's only so much you can bury your head in terms of being an ostrich, and not seeing the problem around us and seeing that we are the root cause of it. Whether that's something we can prevent, something that we can change, something that we can do to anything. It's something that we need to look at ourselves and take a deep, hard look at ourselves in terms of the impact that we have in the world around us. In terms of farming, in terms of ranching, in terms of building new roads. We need to be a little bit more cognizant of these things moving forward in the future. So I'm not saying that, I'm not one of those diehard, we need to be vegan and different things like that, but we need to definitely...
Moderation.
Moderation, yeah, moderation is key. Moderation, and including of moderation, moderate, consumption and different things like that. And I know I'm a larger guy and I like to eat a lot of food, so maybe I should stop eating so much and different things like that. But it's going to definitely take a cultural shift and a huge shift in the way that we think about the world around us to get to that point to accomplish those goals. So that takes us to the end, and I have our sources up here. And I will post the pictures in the Facebook Live for the slides. I did take some good screenshots, so you guys will be able to check out all the slides and all the sources from there. But Rosa, do you have anything that you'd like to add in for today's talk?
No, this was great.
Okay. All right. Thank you guys for tuning in. We're at the 45-minute mark, so I'll let you guys get going. Check out Walking Dead. It should be fun tonight. I know I'm excited. And remember, we have the imperative duty, or duty. It's on us to really try to change the world around us and be the change that you want to see in the world. So, next time you want to throw that plastic bottle in the trash, think twice, because it's going to go to a landfill, or it's going to end up in the ocean or something like that. And take the time to recycle. Take the time to compost. Take the time to do the little things that eventually will add up, because there's 8 billion of us now. There's going to be 10 billion. If everyone just did a little bit more, that's a huge exponential power. And we really need to look at ourselves and, like I said, really try to change the world around us by just changing ourselves, even if it's just a little bit. Next week, I forget what our topic for next week off the top of my head. I believe... I know we'll be doing stem cells and stem cell research in terms of diabetes in 2 weeks. So check us out then. Next week we'll be doing, I don't even know, but it's okay. I'll be posting stuff up on social media. Just take a look. We'll do a new video every week for just a minute long, just to give you a little bit of insight into what we will be talking about, and we'll go from there. But just everybody, thank you for tuning in. I really appreciate it. Oh, yeah. What we got? Oh, it's a great episode next week. Marijuana. Tune in next week. We'll talk about cancer, developmental problems, risks associated with marijuana, and see if that cannabis oil that you keep seeing going around on those memes will actually kill cancer cells. It does in a petri dish. But you know what else does? Bleach. I prescribe that to everybody. 1 gallon daily. Good. All right, everybody. Take care. We'll see you next week. I really appreciate you tuning in.